So this question starts off by providing us with a system of equations. We have y isolated here, which means this is probably going to be a great opportunity to use substitution as our method to solving this system of equations. But let's check the question itself and see exactly what we're being asked to do. So it says, what is the solution xy to the given system of equations? So very straightforward question. There's no tricks involved here. So what do I mean by using substitution? Because we have y isolated, well, there's another option called elimination that I tend to use on the SAT, except for when there is an isolated variable. So the fact that we have y isolated here, that means I can take what we know y is equal to, in this case 7 minus 4x, and plug it into the y for the second equation. So our second equation would become 15x minus 4, and instead of y, I'm replacing y with 7 minus 4x equals 3. So now I have an equation that only has one unknown, which is the x value. I can simplify this further, so 15x, distribute this across, negative 4 times 7 is negative 28. Negative 4 times negative 4x is positive 16x equals 3. 15x plus 16x is 31x minus 28 equals 3. I can add 28 to both sides of this equation, and I'm left with 31x is equal to 31. So, of course, I can divide both sides by 31, and I'm left with x is equal to 1. So I know that x is 1, which means automatically choice A and choice B cannot be the correct answer because only choices C and D have 1 in the x position. So now that I know x is equal to 1, I can take that 1 and plug it into, let me just erase so we can clearly see what I'm doing here. I can plug that 1 value into x. I'm going to choose in the first equation because I just think that's a bit simpler to solve for y. So again, instead of y equals 7 minus 4x, it'll be y equals 7 minus 4 times 1, which of course is the same as y equals 7 minus 4, which is just equal to 3. So y is equal to 3, x is equal to 1, and therefore choice C must be the correct answer.